The high school robotics team designed a robot to toss t-shirts for sporting events. At the current power setting, they calculated the path of the t-shirt tossed from the robot can be modeled by this equation, where x represents the horizontal distance in feet and y represents the corresponding height in feet. Any time that you toss or throw or launch an object, the path that that object follows is a parabola, and we can find an equation to represent that path. This equation is written in Vertex form. If it's written in Vertex form, we should be able to fairly easily pick out what the vertex is. So take a look at the equation. What is the vertex? Not all at once now. 2618. I'm going to draw us a little picture so we can kind of see what this means, preferably a fairly accurate picture. So, a vertex of 2618 means 26 feet in, the t-shirt is going to be 18 feet high. So I'm going to... Is that fairly symmetrical? Symmetrical enough? So this vertex is 2618. And again, that means 26 feet horizontally, the t-shirt will be 18 feet high, because our x value is 26 and our y value is 18. So now that we have the vertex, we're actually going to answer question B first. What is the maximum height of a tossed t-shirt? 18. Remember, the maximum is always the y value of the vertex. And if you think about that, x is the horizontal distance and y is the vertical, the corresponding height, 18 is the maximum height. So 18 what? 18 feet. How far can the robot toss the shirt? From where the toss starts to here is 26 feet according to that vertex. And because this is symmetrical, from that vertex to where the shirt lands is going to be another 26 feet. So how far does the robot toss that shirt? 52 feet. Question C asks you to interpret a little bit. If a fan is 23 feet from the robot on flat ground, would it be possible to catch the t-shirt? Now, if we look at our picture, 23 feet would be like right there-ish. If somebody was standing at that red dot, do you think they'd be able to catch the t-shirt? So your guess is no. Some people might be saying, well, I mean, it's possible. They're within the range of the t-shirt, so, I mean, maybe. How could we know for sure? This is an x value. Could we plug that x value in and see how high the t-shirt is at that point? Absolutely, we could. So use x equals 23 and plug that number into the formula, into the equation. So y equals negative 0.02663. 23 minus 26 squared plus 18. And a student in one of my classes said, you know, I'm really not very good at order of operations. How do I, what should I do first to make sure I get the right answer? And my response was, enter it in your calculator exactly as you see it on the paper with the parentheses and the square, and your calculator will do all of those order of operations for you. This is 17.76. So if you are 23 feet on flat ground away from where the t-shirt is launched, the t-shirt will be 17.76 feet high when it comes directly over you. How high is the rim of a basketball goal? 10 feet. How many people can legitimately jump up and touch the rim of a basketball hoop? So there are some people, but how many people can jump and get to 17.76 feet? Maybe some NBA stars? Maybe? Possibly. That might even be a little high for them. So is it likely that you could catch the t-shirt under normal conditions 23 feet from the robot? No. The path of a shot put released at an angle of 35 degrees. Honestly, this is extra information put in there to try to make you think that this problem is a lot more complicated than it is. Can be modeled by the equation y equals negative 0.01 x squared plus 0.7 x plus 6. And I apologize, that equation breaks over two lines. So if you want to write y equals on the second line so that your equation looks complete, that would be fine. In order to find the maximum height of the shot put, we need to know what are the coordinates of the vertex. So we need to calculate the coordinates of the vertex from standard form. Do you remember how to find the vertex from standard form? Maybe. To find the vertex, you first need to find the axis of symmetry. X equals the opposite of b over 2a. I will probably leave something like this up on the board during the test. X equals opposite of b over 2a. So our a value is negative 0.01, our b value is 0.7, our c value is 6. So the opposite of 0.7 divided by 2 times our a value of negative 0.01. The most common mistake when you're dealing with real-world examples, you must multiply in the denominator before you divide. So when you plug this into your calculator, just put parentheses around your denominator. Do negative 0.7 divided by parentheses 2 times negative 0.01, close your parentheses, and then enter, and that should give you the correct axis of symmetry. So what'd you get? What's the axis of symmetry? Is it 35? So the x value of our vertex is 35. How do we find the y value of our vertex? Plug 35 into the equation. So negative 0.01 times 35 squared plus 0.7 times 35 plus 6. So you should get 18.25 as the y value of your vertex. Once you have your vertex, now we can answer the questions. What is the maximum height of the shot put? Your maximum height is always the y value of your vertex. So 18.25 feet. Okay, part B is a little bit weird. Approximately how far from the shot put thrower does the shot put land? So from where the shot put begins up to the vertex, that's 35 feet. And this parabola is symmetrical, so there's another 35 feet, but I'm going to stop it right there. Why did I stop my little measurement thing right there? If you look at the y-intercept, 6, the shot put started 6 feet high. So there's a piece of this parabola that's missing. So we can say approximately 70 feet. Approximately 70 feet from the shot put thrower, that's where the shot put's going to land. It's actually a little bit more than 70. The reason that we said approximately, I don't care what you write in part C, but write something to help you understand that because the shot put started 6 feet high, there's a chunk of that parabola missing, so it's not perfectly symmetrical on the other side. It's going to be a little bit more than 70 feet. Maybe like, I don't know, 72, 74. We could, once we know how to factor or do other solving methods, we could plug in y equals 0 and figure out what that x-intercept is, but we're not going to go there right now. Okay, on the next page, Intercept Form. This time, the robotics team changed some settings, and now the equation for the tossed t-shirt is this. Okay, one more time, we're going to talk about what this looks like and where the vertex is. Because this is intercept form, we can pick out that our x-intercepts are at 4 and 22. Is that mostly symmetrical? To find the vertex from intercept form, the x value has to be halfway between the two x-intercepts. So what is exactly halfway between 4 and 22? If you can't think of that in your head, remember, find the average. What's 4 plus 22? 26. 26 divided by 2? 13. So 13 is halfway between 4 and 22. To get the other part of the vertex, plug 13 in. So y equals negative 0.3 times 13 minus 4 times 13 minus 22. Did you get 24.3? Sorry, I know I kind of did that a little fast. Sorry. Now that we have our vertex, we can answer the questions, and I'm going to start with B because I think it's the easiest question to answer. What is the maximum height of a tossed t-shirt? 24.3 feet. Now, normally for part A, normally one of your intercepts will be 0, so you can just look at how long that parabola is horizontally. But in this particular case, it's like the robot has moved and shot the t-shirt from 4 feet away from some random starting point. So this is 4 feet. How far is it between 4 and 22? 18. So the robot tossed the shirt a total of 18 feet. From that starting point to the ending point, 18 feet.